So we will start with the first problem. It show that Z6, the additive group of integers modulo 6 forms a group with respect to addition modulo 6. So this group is actually denoted by Z6. So we are going to, in this exercise, we are going to show that Z6 forms a group, and we know the elements of Z6 are 0 bar, 1 bar, 2 bar, 3 bar, 4 bar and 5 bar, because 6 bar is again treated as 0. So for this we will first prepare a table of our addition. So we are going to use your operation is addition modulo 6. So operation will be modulo 6 addition. So we are going to do that. Now I will prepare a table which will have entries as 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar and 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, and the operation is addition modulo 6. So I'm going to add 0 plus 0, which will be 0 bar. Here 0 plus 1, so this is 0 plus 1 is 1 bar. 0 plus 2 is 2 bar, 3 bar, 4 bar and 5 bar. And in the next line 1 bar plus 0 bar, this is 1 bar and this is 0 bar. 1 bar plus 0 bar is 1 bar. 1 bar plus 1 bar is 2 bar. This is 3 bar, 4 bar, 5 bar, and 1 bar plus 6 bar. 1 bar plus 5 bar is 6 bar, but 6 bar is 0 bar. So I will write here 60 bar. Similarly 7 bar will be again 1 bar in Z6, we know this. So now next line is 2 bar plus 0 bar is 2 bar, 3 bar, 4 bar, 5 bar, 0 bar, and 2 bar plus 5 bar is 7 bar, which is 1 bar. I will complete this table in this fashion. And you see that it is not very difficult to do this table. So this completes the table of addition modulo 6. So let me clear those arrows and signs. Now here we have used these things. 6 bar is 0 bar, 7 bar is 1 bar, 8 bar will become 2 bar, and so on. So this is what we have used. Okay, so if you take any two elements of Z6, so let me write closure. So if A belongs to, if any element belongs to Z6 and B bar also belongs to Z6, then the above table says that addition of any two elements in Z6, that addition again comes to be an element which is in Z6 only. So if A bar and B bar belong to Z6, then the above table shows that A bar plus B bar also belongs to Z6. So the closure property is clearly satisfied. Then second is associativity. So associativity is easy to check, so I will leave it as an exercise for you. This addition is modulo 6, so I will write modulo 6. This is always equal to a bar plus b bar plus c bar. So this associativity holds. The reason that one actually always gives is that associativity holds in integers, so it will also hold in Z6 here. So the next is third property is identity. So identity here is, we know that 0 bar will be the identity because any element plus 0 bar will again give you the same element. So identity is 0 bar. And the last is inverse. So every element must have inverse in the group. So if I take the element, can I write the inverse? So a bar plus b bar should be 0. 0 is identity. This means that b bar is inverse of a bar. So the elements are 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar and 6 bar. So the above table now will give you the inverses. So when I go to the above table, I see that 0 bar plus 0 bar is giving me 0. 1 bar plus 5 bar is 0 bar. 2 bar plus 4 bar is 0 bar. Then 3 bar plus 3 bar plus 3 bar is 0 bar. 4 bar plus 2 bar is also 0 bar, and 5 bar plus 1 bar is also 0 bar. So these are the inverses. So this means that inverse of 0 is 0. Why? Because 0 bar plus 0 bar is 0 bar. 1 bar inverse is 5 bar because 1 bar plus 5 bar came to be 0 bar. So from that above squared tables we will get 2 bar inverse is 4 bar, and 3 bar inverse is 3 bar, 4 bar inverse is 2 bar, 5 bar inverse is 1 bar, and 6 bar is not there. So this is the table of inverses. Okay, so we have shown that every element has an inverse in this group, so in this set. So this means that Z6 with respect to addition modulo 6 forms a group. So the first exercise is over here. Now if you go for the second exercise, the second exercise is Z5 star. Now Z5 star means all elements of Z5 except 0 bar. Now it is 1 bar, 2 bar, 3 bar, 4 bar. So this is Z5 star. Okay, and in Z5 we know that 5 bar is treated as 0 bar. This set is forms a group with respect to multiplication modulo 5. This is what is our exercise. So show. So okay, this is my exercise. So the solution of this exercise is again going to be the same as above. So I'm going to say that I'm going to say multiplication modulo 5 table. I'm going to write the elements of Z5, 1 bar, 2 bar, 3 bar, 4 bar, and now I'm going to multiply them instead of adding. Now we have a multiplication operation and multiplication modulo 5. So 1 bar into 1 bar is 1 bar. I'm going a little fast now. 2 bar, 3 bar, 4 bar. 2 multiplied by 1 is 2 bar, 2 to the 4, 2 to the 6, but 6 bar is 1 bar in Z5. So this will be 1 bar, 2 for the 8, so modulo is 3 bar, 3, 6 is 1 bar, 3 is a 9 which is 4 bar, 12 which is 2 bar, then 4 bar, 3 bar, 4 is a 12 which is 2 bar, and 16 which is 1 bar. So this is the table for multiplication modulo 5. So if you take any a bar from here and you choose any B bar from here, you will see that A bar is from Z5 star and B bar is also in Z5 star. So then obviously all these multiplications, these are all A bar multiplied by B bar modulo 5. Okay, this is also in a non-zero element, nobody came 0, so that is also in Z5 star. So this means that first property is that my closure holds from the table. So from the table. Okay, secondly, associativity, I will again leave it to you. So associativity, what is associativity? A bar multiplied by B bar into C bar will be equal to A bar into B bar into C bar. This is all multiplication modulo 5, sorry. Okay, this can be checked. Third is the identity. Identity is E is equal to 1, obviously, because A bar into 1 bar is always equal to A bar. So identity is 1 bar. And the last thing is inverse. A should be multiplied by B bar so that you will get identity, but identity is 1 bar. So this B is in B bar is inverse of A bar. So if I write the elements in my table A bar as 1 bar, 2 bar, 3 bar and 4 bar, these are elements of Z5. These are the inverses. So how we check the inverses? We will go back into the table and find out the identity wherever the identity came. So 1 bar into 1 bar is 1 bar, 2 bar into 3 bar is 1 bar, 3 bar into 2 bar is also 1 bar, and 4 bar into 4 bar is again 1 bar. So 1 ka inverse is 1, inverse of 2 is 3, inverse of 3 is 2, and inverse of 4 is 4 itself. So I will write it here. So 1 bar, 2 bar inverse is 3 bar, 3 bar inverse is 2 bar, and 4 bar inverse is 4 bar itself. So every element here has inverse, and therefore all our 4 things are satisfied, and therefore I finally conclude that Z5 star with respect to multiplication modulo 5 forms a group. So this finishes the second exercise.